So last week we took our trip through all of the domains and kingdoms of living things, including the archaeobacteria, the eubacteria, and the protists, which were all basically one-celled things, and then fungi, plants, and animals, which were our multicellular members of life on Earth. So now we dive into chapter 19, which is all about kind of how all this stuff happened, the history of life on Earth before your history class, right? Like, this is not like who went to war with whom. This is like, how did the different early Earth things happen, starting with how the Earth formed. But before we look at the formation of planets like Earth, let's talk about how we divide up what we call geologic time. It can be hard to get your head around geologic time, the huge amounts of time we're talking about. So the big chunks of time we divide the Earth's history into are called eras. And then we subdivide the eras into smaller chunks called periods. You can also subdivide periods into epochs, E-P-O-C-H, an epoch, but we're not going to bother with that. We're just going to stick with the big stuff. One thing most people don't know about Earth's history is that the vast majority of it, like by a lot, the time that the Earth has existed has had either no life or just one-celled life. So Precambrian time is what we call that huge period of time when there was no life on Earth that we have evidence of, and then there was bacterial life on Earth. So 4600 MYA, you know what that means, right? Million years ago, not meow. But 4,600 million years ago is also what? What's another way to say 4,600 million years ago? About 4.6 billion, right? So 4.6 billion years ago is what that means. So that's basically the beginning of the Earth to 500 million years ago. So that's most of the Earth's history, right? Dividing it up into eras, we have the Hadean era for the first 0.6 billion. Why do you suppose they call it that? Again, you build a time machine, don't go back this far. You would vaporize. It's that hot. The Earth is just formed. It's all covered with lava, and nothing can live there. From about 4 billion to 2,500, 2.5 billion years ago, that's the era when life shows up, right? The archaeobacteria, archaea. It's also the era during which we see the first photosynthetic bacteria, which results in oxygen starting to dissolve into the atmosphere and oceans. And ending Precambrian time is what we call the Proterozoic era. So from 2.5 billion years ago to about 500 million years ago, that's when a lot of the fun stuff starts. That's when the nucleus and the membrane-bound organelles show up. It's when sexual reproduction and multicellularity show up. And at that point, that's when things kind of take off, ending Precambrian time. Precambrian time kind of ends when we're starting to get the more familiar life forms to us. animals. So if we want to do a simple, just to give you a fraction you'll understand. That means that basically Precambrian time is 8/9. 8/9 of the Earth's history. We're in the last ninth, obviously, right? The most recent ninth. But for the other 8/9 of the Earth's history, life has been basically one-celled, if it was there at all. That's big. That's a big, important concept you want to stick in your brain right now for later, in a few weeks when you take the state test. They're going to ask you something about that. For most of the Earth's history, life has been bacteria, or one cell. Questions? Then we get into the kind of more familiar stuff, the more recent stuff, the last 500 million years. Here's what the whole thing looks like, by the way. And it's not to scale, because this is obviously supposed to be 8/9 of it. This is a weird timeline because it goes up. Usually they tend to go down or to the right. But here's the present. So Precambrian time should be 8/9 of it is this red stuff. And the last ninth, they're calling it the Phanerozoic eon. Don't worry about that. But Paleozoic, Mesozoic, and Cenozoic are the eras, and they each have their periods within them. So starting 542 million years ago with the Paleozoic era, which begins with what we call the Cambrian explosion, when, because sex and multicellularity had just evolved, there was this huge branching out and quick evolution of animals into niches. We often, scientists used to call it the age of fishes. That's not a very good name for it, but life was all in the water. And most of the major animal groups showed up in this roughly quarter-billion year period. I mean, fish don't show up till toward the end, but everything is in the water. Paleozoic followed by the Mesozoic. This would be the one you've probably heard the most about. Why? This entirely contains what we know of as dinosaurs. They kind of show up toward the beginning of it, and they end in a spectacular ball of fire toward the end of it. And so it's sometimes called the age of dinosaurs. Again, not a very good name for it. Tail end of the Mesozoic, we see the first mammals, little small furry rodent-like mammals are the first to show up. And then finally we have the era that we're in now, which is called the Cenozoic era, which goes from 65.5 million years ago. The dinosaurs end, and it's still going. Because we like stuff that's like us, we sometimes call the Cenozoic the age of mammals. Also, not a very good name for it. Why do I keep saying that? Why shouldn't it be the age of fishes, the age of dinosaurs, and the age of mammals? Well, in my opinion, because they weren't winning. None of those groups really dominated the earth at any of these times. Because by far the most numerous, and if you're a biologist, that's how you count winning, right? Are there more of you? By far the most numerous living things on the planet, most numerous animals at least, because that's what we're talking about, would be insects. So that's your quick run through the eras and periods. Tomorrow we'll start kind of crawling our way through the early explosive history of the formation of the Earth and how it cooled and conditions got right for living things. And eventually, you'll make your own timeline of the Earth's history. Questions? Perspective is hard with this stuff. Like really getting your head around how much time we're talking about is almost impossible. But to get perspective on how much of that time we've taken up, one of the things we understand fairly well is a clock. So if we were to put the Earth's history on a 12-hour clock, which is the kind we use, sorry, 24-hour clock, which is not the kind we use. It's like military time. This is what it would look like. Starting at 12 a.m., we don't get the first living cells till 5:30 a.m. Photosynthesis shows up around 8 a.m. Eukaryotes close to 1 p.m. Multicellular animals not until 5:30 p.m. And then we see things like backbones, plants, four-legged critters, dinosaurs, mammals, all in the space of like 9 to midnight. Modern humans show up at 11:58 and 56 seconds, meaning about a minute and 4 seconds before midnight. That's how long modern humans have been around in the context of a 24-hour day being the Earth's history. Perspective is good, kind of gives you a sense of what we're talking about here. Good? All right, I got something on the computer for you to do. You'll have to give me a second, but what it is, actually, go ahead and log in. I'll get you there just by Googling it. Questions would be good when that happens. Go ahead and Google Nova Labs evolution, and that should get you there. Now, when you get in, you want to make sure that you are logged in as your school Springboro Google self. Okay, so you log into the Nova Labs program with Google. And that's just to make sure it saves your progress. We're going to be doing this for a while. There are many missions in this program. So you want to make sure it saves your progress. If you go in as a guest and don't log in properly, it'll make you do it over again. There's going to be a point where you get points from me for showing me that you did these things. So make sure you log in with Google as your Springboro Google self. You go ahead and click play game, I think. Did it make you log in then?
Well,